Okay, this is section 8.3 from your text book. Questions from the textbook on 8.3. Using distributive property in equations. So the first one says, John, Alexander, and Brock solved the equation 3 multiplied by x minus 4.3 is equal to negative 2.7, two different ways. Show the two different ways to solve for x. So if I bring this down here, let me just move this down, out of the way. So if I take this equation, there are two ways to solve for it. So I'll just copy it rather than write it again because I'm lazy. The first way is to understand what this says. And what this says is there are three groups of x minus 4.3. So if I was to draw it, I would draw one group of x and a negative 4.3. I draw another x and a negative 4.3, and I draw another x and a negative 4.3 constant. And this would be on the side of a negative 2.7 constant. But instead of saying how much three groups of x minus 4.3 are, what I could do is I could take those and I could divide them into three groups. And instead of having this negative 2.7 here, I could have negative 0.9 on each of the sides of the equation. So instead of saying three groups of x minus 4.3 is equal to negative 2.7, I could say one group of x minus 4.3 is equal to 0.9. But of course, when we do that, we don't actually physically draw it. But when we learned algebra back in grade 7 and 8, we learned how to model it quite a bit. So what we would do is, just like in the drawing, I would divide this side into three groups, and I would divide this side into three groups. Because with algebra, whatever you do to one side, if you do the same thing to the other, you maintain equality. So dividing this side by 3 results in getting rid of that multiply by 3, and you have one group of x minus 4.3 is equal to negative 0.9. So simply by dividing by 3, you end up with a one-step algebraic equation, which is fairly easy to solve, because you just have to get rid of the constant by adding 4.3 to both sides, and x will become 3.4. Is that right? Did I do that the right way? Austin, is that right? Okay. The other way to do it is, if you think about the drawing again, and you have an x and a minus 4.3, and you have an x and a minus 4.3, and an x and a minus 4.3, and that's equal to negative 2.7. Really, if you analyze what this is, well, 3x's minus 4.3 is really 3x, which is right here, and 3 minus 4.3 is negative 12.9. So instead of dividing both sides by 3, you could do what's called expanding using distributive property. So you have 3x's and you have 3 negative 4.3s. So you have 3x minus 12.9 is equal to negative 2.7. The difference between this is that in this, if you divided both sides by 3 to start, you gave yourself a one-step algebraic equation to start. And if you have expanded instead of division, you just gave yourself a two-step, because now we have a coefficient, and a constant. Get rid of your constant by adding 12.9 to both sides. You get 3x is equal to 10.2. Divide both sides by the coefficient, and x equals 3.4 still. Last part of the question says, if the equation was three groups of x minus 4.3 equals 1.7, which method would you use and why? Well, the answer to this question is we would use the second method. And the reason why is, if I divide both sides by 3, and I take my calculator, and I go 1.7 divided by 3, it ends up giving us a repeating decimal, right? And because it's a repeating decimal, you would not want to go x minus 4.3 is equal to 0.56 repeating, because then adding 4.3 to both sides makes it a little bit more difficult when it's actually a non-terminating 6. So if I divided both sides by 3, it would make it much more difficult for me to do. Question 2, Cole and Rebecca used two different methods to solve the equation x plus 1, or half of x plus 1 equals 3/5. Cole multiplied both sides by a common multiple, 10, to finish his work. So if I take his equation, and if I multiply both sides by 10, and again, whatever you do to one side, if you do to the other, you maintain equality. So multiplying by 10, because you're multiplying two fractions, you can cross-reduce to make 5 over 1. And when you multiply the numerators, you'll be multiplying 5 over 1 by x plus 1 over 1, or just 5 multiplied by x plus 1. 5 multiplied by x plus 1, which will be 5x plus 5. Now, a lot of students who make a mistake say 5x plus 1, but you got to fully expand using distributive property. And over here, multiplying it by 10 will result in 6 over 1, or just 6. Now, once you get this, of course, you have an equation with no fractions in it anymore, so you subtract 5 from both sides. 5x will equal 1. Divide both sides by 5, and x will equal 1/5, or, as a decimal, 2/100ths, or 2/10, excuse me. Rebecca wrote the equation as this. So she said, if I think about this, what does this mean? Well, this really is half of x plus 1. And another way to write half of x plus 1, is half of x plus 1. So she reinterpreted it as that. So if you write half of x plus 1 is equal to 3/5, to get rid of this, if I divide first, I'm going to divide both sides by a half. Divide this side by a half. When we divide by a half, we found it much easier to not do division. You could, but multiply by the reciprocal. And you would then have x plus 1 is equal to 6/5. Subtract 1 from both sides, and x will equal, well, since 6/5 is really 1 1/5, 1 1/5 take away 1 is simply a fifth. Which method do you prefer? Well, the option is yours. Now we get into some simpler questions. Question 3 is just distributive property with decimals. Expand. I'm going to do it both. I'll alternate ways. Expand using distributive property. You get 2x plus 3 equals 7.6. Subtract 3 and you get 2x equals 4.6. And finally, x equals 2.3. If you divided both sides by 2, you still end up with the same answer. Question 4, we'll use division first. Divide both sides by -1. X minus 65/100ths is equal to a positive 2.8. Add 65/100ths to both sides, and x will equal 3.45. I think we do this one distributive property this time, so I'll expand. 3x plus 13.53 is equal to -3.57. Subtract. Did I do that right, by the way? Yeah. For those of you who are listening still. You end up with 3x is equal to, what's that going to be? 27.1. Negative. Divide both sides by 3, and x will equal, brain can't work. Is that right? Did I make a mistake somewhere? Oops, I made a mistake. It's 17.1. So divide 17.1, not 27.1, 5.7, which is going to be a negative 5.7. Question 6, division first. Divide both sides by 3.6, negative 3.6, excuse me. And 1/4 minus x is equal to, which is a half. Of course it is, because it's half a 3. Then you're going to subtract 0.25 from both sides. Negative x equals negative 0.75. And if that's true, then x equals a positive 0.75. If you wanted to, you could actually show division by -1 if you want. But x equals 0.75. Oops, I made a mistake. Let's go back in time. So apparently I made the mistake again. So 0.18 divided by 3.6 is 0.05 instead. So 0.25 minus x equals negative 0.05. Subtract this from both sides. Negative x equals negative 0.3. And then x will equal a positive 0.3. If you want to do this again, you can. Next question. Actually, it's quite easy, to be honest. But what we'll do is we'll simply look at it and say if half of x plus 1 is equal to negative 3/4, if I double this side and I double this side, instead of having half of x plus 1, I will have all of x plus 1 equals 6/4. Or 1.5. If you double 3/4, you have 1.5. Subtract 1 from, negative 1.5. If you subtract 1 from both sides, you'll end up with x equals negative 2.5. So your answer is x equals negative 2.5. Now, if this is multiplying by 1/3, I'm going to divide by 1/3 to get rid of it. 5/2 divided by 1/3 can be achieved by the same operation as multiplying by the reciprocal of 1/3. So over here, I'm left with x minus 2 is equal to the product of 5/2 divided by 1/3 or multiplied by 3/1, which is 15/2, which is 7.5. Add 2 to both sides, and x will equal 9.5. I guess we have to expand this one, don't we? All right. Well, how many of you expanded? How many divided by 3/4 on both sides? How many expanded using distributive property? How many didn't do this question? Oh, excellent. All right, Sierra, if you had to do it, would you divide both sides by 3/4 or expand using distributive property? Let's do that. I probably would too as well. Divide by 3/4 and divide by 3/4. And dividing by 3/4 is the same thing, Sierra, as multiplying by what? 4/3. So x plus 2 is equal to the product of 1 1/3 times 4/3, or the product of 4/3 by 4/3, which is 16/9, which is 1 7/9. Subtract 2 from both sides, and x will equal negative 2/9. Is that right? I think so, isn't it? Yeah. Negative 2/9. Question 10. Question 10 is an interesting one for sure. Those of you who didn't do it, who didn't do this one? Okay, Cole, what do you think you'd do here first? What's your gut say to do first? Both sides by what? By 2? No. You could multiply by... If you multiply both sides by 6, what would happen? Would you have any fractions left if you multiplied both sides by 6? No. Another alternative is just multiply both sides by 3. And if you multiply by 3, you're left with just 2 groups of 5 minus x on the side, right? So 2 groups of 5. There's many ways to do it. I'm going to do it this way. Equals 21/6. Is everybody okay with that first step? Right. All right. And then I'd probably divide by 2. And divide by 2. Dividing by 2 is the same thing as multiplying by a half. So you can do that, which will be now 21/12 equals 5 minus x. So far, okay. Then I subtract 5 from both sides. And negative x would be left over here. And 21/12, take away. Does anyone know what 5 is as a denominator fraction of 12? No, it's 60/12. 60/12 is the same thing as 5, right? How many 12s in 60? Well, I'm just telling you, 5. So once you have that, 21 take away 60/12 equals negative x. Negative 39/12 equals negative x. And negative 3 3/12, or what's 3/12 in lowest terms? A quarter, equals negative x. It's a lot of work. Your final step is therefore x equals 3 1/4. Because you divide both sides by negative 1. Question 10 is the other way to do this than what we just did. So remember I said if you multiply both sides by a common multiple of all of the denominators, in this case 6, this would have been a much better way to do it. And I'll show you what would happen. Over here, I'd be left with 7. Over here, I would be left with two groups of 5 minus x, or two groups of 10 minus 2x, or 20 minus 4x. So if I was to multiply both sides by 2, or 6, excuse me, if I thought of this as being this instead, once I cross reduce, 6/3 will reduce to 2/1. I'll have two groups multiplied by this, which will end up giving me this expression here. And I think for most people, given the idea of all the fraction sets that we had to use with the last way we did it, this is a much easier way of doing it, right? You'd have negative 13 equals negative 4x. Divide both sides by negative 4. And x would equal positive 3 1/4. A lot easier than the first way we did it, correct? So if you have an equation, moral of the story is if you have an equation with fractions, if you acknowledge multiplying it by a common multiple of the denominators will give you an equation that does not have fractions, that to me was a much easier way to solve that equation than the first way. So that's up to you though. Question 11, multiply both sides by 3. Subtract the constant. Question 12, getting easier. Look at this. Oh, this is exciting. Anyone else excited by this? X equals 0. I know. Question 13, 14, 15, and 16 are your story problems. And if you struggled with anything, you probably struggled with this. So let's follow along as we go through this. Question 13 says the mean of two numbers is 3.2. So mean means, of course, average. One of the numbers is 8.1. What's the other number? So if I think about how I would get average, if I added two numbers together, in this case I'm going to use x plus y, and since there are two of them, to get the average I would have to divide by 2 to get the average. So one number plus another number divided by 2 would be x's and y's average for those two numbers. But since we know one of them, it says the one of the numbers is 8.1, I'm going to erase y and you could erase x too, it doesn't matter, and make that one 8.1. And since we know the average is 3.2, putting this down for an equation instead will also allow you to solve for the missing number in that average, or x in this case. So x equals the number, the missing number. Multiply both sides by 2. X plus 8.1 equals 6.4. Subtract 8.1, and x will equal 1.7, negative 1.7. So therefore, the three numbers are 8.1 and negative 1.7. You can be guaranteed with 100% certainty that this question will be on your test. Exactly as worded as that, except different numbers. Yeah. Question number 14 says 2 equilateral triangles differ in their side lengths by 1.05. Now, I've done this question, and I realize I probably should have written it differently, but I think what it means is that the side lengths are, in total, 1.5 meters each different. So if this one is x, x, and x, and since their side lengths differ by 1.5 meters, I think what they were trying to say is that in total the perimeter differs. The perimeter differs. I should have rewritten it like this. So if you had difficulty with it, I'm going to reword it right now. By 1.05. So if there's three sides, and these are all x's, and there's 1.05 meters in the difference, if I take the 1.05 and divide it by the three side lengths, so 1.05 divided by the three side lengths, that means that each side here is this much bigger, I think. Because otherwise you get a repeating decimal. Who solved it and got a repeating decimal? I think yeah. So I think this is what we're supposed to do. But I might be wrong. We'll see how it goes. And if not, we'll figure it out later. So the first step was to draw your first one. And since it's an equilateral triangle, all sides are the same length, which means x, x, and x is an appropriate variable allocation, because all three of them will be the same length. And since this one's bigger by 1.05 meters, then we will make it like that. So then it says the perimeter of the larger triangle is 0.83 meters larger. So we could do it one of two ways. You could say this side plus this side plus this side equals 9.83. Or we could put on our big boy and big girl shoes and say that instead of repeated addition, we can say that three sides of this is equal to the perimeter of the larger triangle, which is 9.83. If we expand that, we'd get 3x plus 1.05 equals 9.83. And if we subtract the constant from both sides, we get 3x equals 8.78. Hopefully this works. 8.78 divided by 3. Please don't be repeating. Oh, poopy darn. Okay. I'm going to press pause and make a correction. So it was the way it was supposed to be. It was supposed to be this. Each of those sides is 1.05. And if we take that and go three sides of this is equal to the perimeter of 9.83, divide both sides by 3, then one of those side lengths is equal to 9.83 divided by 3 equals, oh, poopy darn, 3.3 approximately. Why did this not work out? Also, did I make a mistake somewhere? My colleagues tell me that I think this is all we had to do, and that's why it's not working. Just create the equation. I don't think you have to solve it. I think I made a mistake somewhere. If I did, leave a comment in the video and explain to me what I did wrong, and I'll reward you with a chocolate chip muffin that Carly ate. Question number 15 says, on a typical day in the greater metropolitan area of Badek, the daily average temperature is negative 0.2 degrees. If the low temperature was negative 3.7, what was the high temperature? So this is exactly the same question as the one we had before. So the high temperature plus the low temperature divided by 2 will equal the average temperature. So since we know the average temperature is negative 0.2, and we know that the low temperature is negative 3.7, the high temperature and the low temperature combined divided by 2 will give us the average. So double it. X minus 3.7 equals negative 0.4. Add 3.7 to both sides, and X will equal 3.3 degrees. So therefore, the high temperature, I think, must have been 3.3 degrees. And I think this is the second last question. Lucy bought 3 jars of spaghetti sauce. She used a coupon for each that reduced the price of each jar by 75 cents. If she spent $6.72 altogether, what was the regular price of each jar? So X is going to equal the regular price of the jar of spaghetti. Since she bought 3 of them, each of those jars, X minus 75 cents, would be the sale price. And 3 jars at the sale price is what she spent, which would have been $6.72. So of course, now that we've created our equation, there's many ways we can solve. We can expand or divide first. If 3 jars cost $6.72, then 1 jar costs $2.30. Oh heavens, $2.34. Is that right? No, $2.20. Arg. Brain not working. $2.24. I don't think I did. $2.24. And if the sale price of a jar was $2.24, if I take off the coupon or add the coupon back onto the price, I get X was equal to $2.99. And therefore, the original price was $2.99 a jar. And I'm just going to do this last question, then I won't do the other part, because if you can do this one, you can do the last one. So the only difference between this question and the ones we've been doing is you have to combine a little bit of chapter 5 in here, because when we expand, you're going to get 2x plus 6 plus 3x plus 6 is equal to 0.5. And when you have that, you have the ability to gather like terms, because in chapter 5 you learn to add. This is a polynomial of 6 terms, but there are like terms, which means 5x plus 12 equals 0.5. And now we have 5x equals negative 11.5. And finally, x equals negative 2.3.